Okay, let's try to understand the problem first. Given a binary tree, imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. So if you take that, this is the binary tree given to us, and we are standing somewhere here and looking at the binary tree from this side, then I should return all the nodes which I see from this side. So in this case, it will be the nodes. Let me change the color, and I take something like red, and this should be I should return back node 1, node 3, and node 4. That's great. But if I have some other problem, like take something like this, if I have 2 and then 3 and then 4, 5, 6, 7, 8, and then 9, then if I stand here on the right side and if I look at this binary tree, then the nodes which I would see from here would be 2, 4, 6, 8, and 9. So what comes first to the mind when we see this problem? It's definitely clear that something kind of like a level order traversal of a tree. So we visit this level, then we visit this level, this level, this level, and this level, and pick the most right element what we see from here. So we can solve this problem by using a queue and a BFS. Now let's try to write the code. So let's declare a vector where we will save the results. So I will say std vector int, and I will save the results. I will declare a queue to do our BFS. So std queue of type tree node pointer, because the elements type which is stored in the queue will be tree node pointers. So I would say it's like queue, and the first element what we have to push in the queue is the root itself. So we push root. That's good. And also one variable to track the levels. So I say level equal to 0. Great. Now let's look through the queue. So while not queue dot em empty, and then the number of elements at each level will be the size of the queue. Right? Get it? So at level 1 we'll have only 1. At level 2 we can have 2. This is 2 and 3 in the example. Level 3 we can have at the max 4, but here it is 2 in the example. So I say int elements, which is number of elements. I would say maybe write it number of elements is equal to q dot size, and that will be the number of times we'll loop in. So int I equal to 0, I less than number of elements, then I plus plus. Now let's read the value what is in the front of the queue. So it will be like a tree node pointer, and I would say as a node is equal to q dot front, right? And then we pop it from the queue, and then once we have it, that will be the first element which we'll see. So we have to save this element. That will be our result. In this case, it will be 1. And then we move to the right side of the node, which will be 3 in the example here. So what we'll do, and it depends on the level, so we have to save only the first element. So if I say if result.size is equal to level, so it will say only the first element, then I would just say result.pushback what? That will be node and then the value of this one. Now if there is a node on the first, I have to move to the right side. So I say if node right exists, then q dot push node right, and if node left exists, then I have to say q dot push node left, right? That's good. And each time the for loop is completed, I will increase the level by 1. At the end, what I have to do, I have to return the result. As simple as that. Return result. Cool. Let's try to run this. Okay, there is some error. Results. Sorry. Or maybe I think let's take this as result. That would be much better. Cool. And that's it. And then let's submit this one. Okay, yeah, we didn't cover one case, which will be when the root is null. So if I say if root equal to null, yeah, then just return the empty result. Cool. Let's try to submit again. Cool. That was fastest. That's nice. Next, let's see the time complexity and the space complexity of this algorithm. See this algorithm, which is BFS, breadth first search. We visit each node of the tree at max once. So you can simply say that the time complexity of this algorithm will be of the order of big O of n, where n is the number of nodes in the tree. Right. So change the color. What will be the space complexity of this algorithm? If you see this, the extra space what we use here is the queue. It's this queue. And what will be the maximum size of the queue will depend on the diameter of the tree. So the space complexity will be of the order of big O of D, where D is the diameter of the tree. And that will be the maximum number of elements what will be there in the queue. If you look online, you can just check that this D will be at the max and by 2. And there is one more good problem in Leetcode, which is about calculating the total number of nodes in a complete tree. And maybe in next coming videos, I will try to go through that problem and try to explain that problem and how to solve that problem as well. Okay, see you. Bye-bye.